All right, everyone, it's Casual Dr. B, the Bridge for Math, wearing my fish shirt with trout. Hey, good to see you today. We're going to cover something called a zero. Notice my crazy accent, zero. I'm not talking about the value of zero or nothing or nada. I'm talking about something very important in math called a zero. Well, let's define it. Well, a zero is an x input that results in an output f of x equal to 0. Clear as a bell, right? No, I'm just kidding. I don't blame you for looking at me saying, say what? Okay, let's try it again. How about this? Zeros are the x inputs, so we like that, the x inputs that are solutions to making a polynomial function equal to the value of 0. Are you kidding me? Are you saying I'm bullshitting again? Okay, nope, that's X-rated, we can't say bad words. Come back. Again, say what? The best way to see what a zero is through an example. So let's check one out. Let's find the zeros of this polynomial function p of x equals x squared minus x minus 6. Notice the different letter. I could have put f of x for a function f, but we're calling this a function p, usually to represent polynomial. And when we deal with zeros, we get to big powers, x to the 10th or any crazy exponent. Here's just a squared. So here's our strategy. What we want to do is we want to set this function equal to 0 and solve for x. So p of x now becomes 0. We're going to try to find the x value that when we plug it into the function adds up to 0. So what's a way to solve a quadratic equation? And let's make this connection. If you've been watching some of the Bridge for Math videos, we showed you how to solve a quadratic equation. And you remember one of the things is make sure you set it equal to 0? It shows up a lot. When you're doing rational inequalities, make sure it's set up equal to 0. You're going to discover that concept flavors the zeros discussion here today. Basically, you're going to find out that the zero concept helps us distinguish between positive and negative. Enough of that, let's get back to this. So we factor the quadratic equation, because it's pretty easy to factor. And something called the zero product property, something multiplied by something equals 0. What does that tell you about these factors over here? X minus 3 is a factor and x plus 2 is a factor. It tells you that one of them, or even both of them, have to equal 0 to multiply and give you a 0. So let's see, x minus 3, what x value will make that thing 0? Sure, x is a positive 3. X plus 2, what will make that factor equal to 0? Yeah, add negative 2 for x, and negative 2 plus 2 will give you 0. Turns out these values, x equals 3 and x equals negative 2, are zeros. Again, here's the trickery. X equals 3 is a 0. You're like, 3 is a 0. Do you see how you have to be careful? Math is a language. I just want to bring you to speed. I like to say 0 so it gets you away from that concept of the value of nothing. X equals 3 is a positive 0. X equals negative 2 is a negative 0. That will help you out when you look at more advanced moves like Descartes' rule. Let's continue. Wouldn't it be nice if there was a visual way to understand what a 0 was? There is. Awesome. Let's check it out. Geometrically speaking, zeros are x-intercepts on a graph. So I've actually graphed the function we were looking at, x squared minus x minus 6. Do you remember negative 2 and 3? They were the zeros. Well, they also are the x-intercepts, where they cross the x-axis. Now, why would that 3 be so special? Well, that 3 is where you're at neutrality. You're on the x-axis, that's y equals 0. You're at neutral zone. What happens when you get bigger than 3? You get a y value that's positive. Positive, negative. Do you think that might be important if you're studying some relationships, like a business? When are your profits positive? When are you not making money? You want to know positive and negative. Another advanced theory is there's something called the intermediate value theorem. That says if I have a negative value for my function to the left of 3, and I have a positive value for my function to the right of 3, it has to cross 0. Kind of cool. So how did I get this beautiful graph? Well, you could graph it the old-fashioned way. Plug in points into your function. Calculate y values. Or, again, I keep trying to let you know there's a cool thing on the internet. You can graph things at wolframalpha.com. Here's the simple syntax code that you can type in, and you can get this pretty graph. But again, I want you to see, geometrically speaking, 3 and -2 are x-intercepts, also known as zeros. You will also hear them called roots of an equation or a function. You'll also hear them called solutions to an equation or a function. So I can see you get confused, but if you bear with me and recognize they use the same word to mean the same thing, hello, howdy, hi, don't get panicked, we can handle the heat. Here's the type of question you might experience on an exam for an algebra class. Show that -3 is not a zero of this polynomial. Notice we upped the game. Notice this polynomial is a lot bigger. It's got a lot of x's. 2x to the fourth minus x cubed minus 13x squared plus 5x plus 15. That's a lot. Well, let's go back to the definition. They're saying show that -3 is not a zero. Well, what if it were a zero? What would happen? Well, if it were a zero, you'd plug in -3 wherever you see the x. You'd add up all the terms, and it would add up to 0, the value of nothing. We'll see what happens. Now, I want you to pay attention here. We're using all these coefficients, the 2, the -1, -13, 5, and 15. We're plugging in -3. Does this look like a book nightmare of calculators and addition and subtraction? Crazy, raising to exponents. Look what happens. -3 to the fourth power is 81. You can use your calculator, whatever you need. But you do the work, and I have all the numbers written here so you can check the video and check your answers. But it adds up to 72. I put 72 in sexy red to highlight it. 72, that is not 0. So what can we conclude? We can conclude that x equals -3 is not a 0. That means it doesn't meet the definition of a 0. So that's by using the definition. It also means that x plus 3 is not going to be a factor. So I'm going to give you a taste here, see if you're really listening for the A students out there, the crazy ones. X minus some number c is how we look at doing zeros, if you're look at some other tutorials. So x minus c, where c is -3, would make a minus would make it x plus 3. So that's just in case you're catching that. But let's continue. The question also says, show it's not a 0 by the definition or by using synthetic division. So this is just a taste of how to do synthetic division. If you've ever heard of the term synthetic, it means similar but different. A unique formula like synthetic oil. Notice I have an upside down division sign. That's kind of hinting at synthetic division. Well, we still do the -3, and this -3 again is considered a C value. You plug in the C value to see if it actually becomes a 0. Where do these numbers 2, -1 come from? See all these numbers? They come from the coefficients of the polynomial. 2x to the fourth, there's a 2. -x cubed, there's the -1. So you see where those come from. Now, you're going to probably have to watch this video a couple times to catch it, but I want you to pay attention. The first 2, you always bring it below the line. Notice the arrow going below the line. This number out here, -3, multiplies by every number below the line. So I'm going to walk you through the synthetic division, and I want to see if you catch this conclusion. So what's -3 multiplied by 2? It's -6. Follow the arrow. -6. Everything on the inside here you add. So what's -1 plus the -6? -7. You see the arrow flowing down to -7? Now -7 is below the line, so what do I multiply the -3 by? The -7. What's -3 times -7? Positive 21. Watch that arrow. Positive 21. You add everything in here. See the pattern? What's -13 plus 21? Positive 8. Notice the arrow. 8's below the line again. What do? Multiply it by this -3. So it's an interesting pattern. Just kind of have to memorize it. -3 times 8 gives me a -24. You add it to the 5. 5 plus -24 is -19. Continue one more time. -3 times -19 is positive 57. What's 57 plus 15? 72. Whoa! 72? Whoa, what the? That's the same number you got when we used the definition of plugging -3 and doing all that crazy calculations. Now, if that doesn't blow you away, you're different. That freaks me out. This one, all I did is multiply and add. This one, I had exponents and crazy stuff. Gave me the same result. That's important to know. Synthetic division can actually be a lot faster to do. And I actually encourage you to get good at synthetic division because you can go fast to figure out if something's a 0 or not. So this number right here at the very end is called the remainder of synthetic division. If that remainder is equal to 0, then you have a 0 or a root or a solution. But at 72, we already knew that x equals -3 is not a 0. So hey, you might have to watch this a time or two, but good luck. This is the bridge casual mode today. Take care. My best to you.